All right, we're going to talk about section 7.3 today, which is talking about ratios, proportions, variations. We're going to talk about how to write a ratio, what a ratio is, how to calculate unit pricing, how to solve proportions, how to deal with direct variations versus inverse variations, and how to deal with combined or joint variations. So ratios are a pretty common thing. One of the most common ones is a batting average for a baseball player. When we're talking about slope of a line, we're actually talking about a ratio of the rise over the run. Anytime we're talking about a comparison of two things, the comparison of boys to girls in a class, or different things like that, we're talking about ratios. It's a comparison of two different quantities. So ratios are usually written as fractions, A over B, but they can be written as the expression A to B or the expression A colon B. So one of the things you do have to watch out for is when you're comparing ratios, you've got to make sure that the units of measurements are the same. So you've got to make sure that they're both in feet or they're both in inches or whatever the case is. So here's an example. We have 8 hours to 2 days, and we want the ratio. So we cannot just write 8 to 2. We need to make sure that we either have both of them written in terms of days or both of them written in terms of hours. Well, it's a lot easier to write how many hours in a day than it is to write how many days in 8 hours, because that would be a fractional number. So we're going to take the 2 days and we're going to write down as 8 hours over 2 days, but then we need to convert the number of days to hours, so it's going to be 8 hours over 48 hours, and then we're going to simplify that fraction and get 1/6. Okay, so now we can talk about unit pricing. And with unit pricing, what we're trying to do is figure out how much it is per unit or per item. You know, how much is the hamburger per pound, or how much is the cereal per ounce, different things like that. So you're trying to figure out cost effectiveness. So here we have, find the unit price of a 16-ounce box of cereal that has a price of $3.36. So to figure out unit pricing, we're going to take the price and we're going to divide it by the number of units. So we're going to take the 336 and divide it by 16, and we're going to end up with 0.21. So that tells us that we're paying 21 cents per ounce for that box of cereal. So if I wanted to compare different cereals and I wanted to figure out which one's the cheaper or which store has the cheaper price, I could figure out the price per ounce. So when we write a proportion is just simply two ratios that are equal to each other. So 1/2 is equivalent to 3/6. So this is a valid proportion. Those two proportions are equal. If I were to cross multiply this problem, 1 times 6 and 2 times 3, I know that they're equal if the two ratios multiplied together equal each other. This is called cross multiplying. So in this example, the A and the D value are what we call the extremes, and the C and the D value are what we call the means. So whenever we talk about cross multiplying, we're talking about the product of the extremes equals the product of the means. And so that's what this expression means here. In other words, we're cross multiplying. So we want to multiply A times D and C times B, and then we want to solve the problem. So here's an example of cross multiplying. We want to multiply the 4 times x and get 4x. And then we want to multiply 5 times 22. So 4 times x is 4x. 5 times 22 is 110. And I'm going to divide both sides by 4, so x equals 55 divided by 2, which we could write as a decimal, and that would be 22.5. All right, so the next topic we're going to look at is direct variation versus indirect variation. So direct variation is an expression that says y varies directly as x, or y is directly proportional to x. So if there exists a non-zero constant k such that y equals k times x, or you can also write that as y over x equals k. So k is the constant that represents the constant of variation. So that's what we're talking about with direct and indirect variation. So the first step is write the variation equation. So that would always be that equation that we had, y equals k times x. That's what they mean by the variation equation. And then substitute the initial values that you have in there to find the value of k. K is your constant. And then rewrite the variation equation with the new values and the k value, and then solve that problem. So for example, suppose y varies directly as x, and y equals 45 when x equals 30. So as soon as we see that y varies directly as x, then we're going to write down y equals k times x. We're going to substitute in what we know. So we know the 45, and we know the 30, and we're going to solve for k. And when we do that, we end up with k is 3/2, or k is 1.5. So now we want to do the problem again, but this time when we do it, we're going to put that value of 3/2 in for k. And since they're giving us x equals 12, we're going to put that in for x. And then when we solve, we get y equals 18. So since this is a direct variation, we know that since y was equal to 45 when x was 30, then when x is 12, y will be 18. And that's our direct variation problem. So here's another one. Suppose that x varies directly as y. X is equal to 27 when y is equal to 6. So again, as soon as we see that direct variation statement, we're going to write down y equals k times x. Substitute in what we know, and we're going to solve the problem. So k is going to equal 6 over 27, which can reduce to 2/9. And now we're going to take the same problem again. We're going to put that k times x, and we're going to put, this time, we're going to put the 2/9 in for k, and y is going to equal 2. And now we need to solve for k, or solve for x, I'm sorry, and we end up with x is equal to 9. Now there's also a direct variation as a power problem, and that's referring to if it starts talking about y varies directly as the second power of x or the third power of x or something. And then again we have a formula y equals k times x to the nth power, whatever that nth power is. So again, as soon as you see a problem that says it varies directly as the fourth power of x, then you'll go to this formula. So the area of a circle varies directly as the square of its radius. So it's a different way of saying area equals pi r squared. So if area A represents the area and r represents the radius, then for some constant k, we don't know what it is, area equals k r squared. So when we're talking about an inverse variation, the difference between inverse variation is that we're going to be looking at these formulas x times y equals k. Remember the other one was y equals k times x. So that's the difference between the two. Another way of looking at this is that y equals k over x. So if you see that it's talking about an inverse variation in the problem, then you're going to use the k over x problem. If you see it says that it varies directly, then you're going to use the y equals k times x problem. So the weight of an object above Earth varies inversely as the square of its distance from the center of the Earth. If an astronaut in a space vehicle weighs 57 pounds when 6,700 miles from the center of the Earth, what does the astronaut weigh when he's 4,090 miles from the center of the Earth? So a couple things you see. You see that it talks about inverse variation, but it also talks about inversely as the square. So we're going to be looking at the formula y equals k over x to the nth power. So again, as soon as you see that, you're going to remember this formula. So in this case, y is the weight and x is the distance. So now when we plug all this information in, the weight was 57. They were 6,700 miles from Earth. So when we do the mathematics on this problem, we get that he's approximately 153 pounds. Okay, so let's go through and do this. When we do 57 times 6,700 squared, we get a very, very large number. And the number that you get on your calculator is 255,873,0000. So we're looking at 558,730,000 is the k value. So I could take that number and put it in here and get 255,873,0000 and divide by, put it back into the formula. This is my k value now. So if I put it back into the formula and I'm looking for the new weight, I could take that 255 number. I'm just going to put 255 dot 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 divided by the new distance, which is 4,900 squared, and that's where we get the 153 pounds. So I've skipped a couple steps, but just you still get the right idea. All right, so here's another one. For a constant area, the length of the rectangle varies inversely as the width. So the length of the rectangle varies inversely as the width. So as soon as you see that again, you know that you're looking at this formula, y equals k over x. So we know that the area formula is length times width. So we're going to go through and substitute in length and width to the problem. W is the width, L is the length. So when we do our mathematics, area equals length times width is 2,700. So now if I change the value of, it says find the length of the rectangle with the same area if the width is 18. So if we go back to our formula again, area equals length times width, the area doesn't change. We're trying to find the length, and the width is now 18 feet. And if I divide both sides by 18, the new length is 15 feet. All right, so a joint or combined variation is if one variable varies as a product of several other variables. It's said to be a joint variation. And if they involve this inverse and direct variation, they're called a combined variation problem. So if I gave you an example and I said m varies jointly as x and y, it can be expressed this way. Because it varies jointly, then you're going to set it up as this equation and you're going to solve this or use this type of problem. So you just have to look very carefully at the problems and see what they're dealing with when you're setting it up. So let's look at this. If it says m varies directly as x and y, x and inversely as the square of y, you can express it this way. So these are our formulas that you need to keep in mind as you're going through these problems. So let's look at this. The strength of a rectangular beam varies jointly as its width and the square of its depth. If S represents the strength, W represents the width, and D represents the depth, then for some constant K. So we're looking at that formula, M equals KXY. M is S, which is the strength because it varies jointly. K is always what we're looking for, and it says the width and the depth squared, so the width and the depth squared. So this would be our formula that we would use, and then we would have to substitute in numbers as we got them. All right, I hope this helps. I hope you have a great day. Keep in touch with me and let me know if you're needing any help on this material. Have a great week.